Hi students, now we are going to define what is gravitational field intensity and also derive an expression for that. Before that, we all have learned first what is magnetic field. Suppose if you take a bar magnet, surrounding this bar magnet there will be a region inside which any other magnetic pole or any other magnetic substance like iron nail experiences a attraction. So this area is limited. If the magnet is so powerful means little more area it will be having. So this area surrounding a magnet is called magnetic field. Like that, if you take electric charges, positive charge and negative charge, there will be some region surrounding that given charge inside which any other charge will experience a force of attraction or repulsion. Okay. So this region, as we have defined as electric field and magnetic field for the charged particles and the magnetic poles. See, in a similar way, if you consider any given mass, surrounding the mass there will be a region or space called gravitational field. Inside the field, if any other mass will enter means it will be attracted. Understand? You take for example Earth. Our Earth is a planet and it is having a mass 10 to the power of 24 kilogram. So because of this mass, our Earth will be surrounded by a field inside which an apple as well as the moon are getting attracted. But apple is a body at rest, so it is falling towards the Earth. While moon is not a resting body, it is a projected body. It is a satellite. It is a moving body and hence it is not falling towards the Earth. But on both the apple as well as the moon, these two objects are present inside the gravitational field of the Earth. So what is gravitational field first of all? It is a space or area surrounding a given mass, inside which any other mass will experience a force of attraction. Now always the given mass is called as a source mass. Source mass means it is a given mass. And in its gravitational field, if any other mass enters, it will experience an attraction. That any other mass is called by the name test mass. Suppose the source mass is the Earth means apple is called the test mass. Suppose if a source mass is the Earth, then the moon is called the test mass. It is experiencing a gravitational force. So my dear students, you keep it in mind, the given mass is always called by the name source mass. And the test mass is experiencing a force of attraction. So here one thing you should remember, that the test mass only will be attracted towards the source mass. So this is the direction of the force. Okay, this is the direction of the force acting on the test mass. It is bound to the source mass. So the direction of the gravitational force acting on the test mass is towards the source. And here I have taken the source mass as m1. So gravitational field of the source mass only I have to consider. So inside the gravitational field of the source mass, I have to place another mass called a test mass, and it will experiencing a force. Preferably if m2 is equal to 1 kilogram, that is called as unit mass. Whether it is 1 kg or 10 kg or 100 kg, it will be attracted towards the source mass definitely by a force of attraction, isn't it? So the definition of gravitational field intensity, if you want to find the intensity of gravitational field at any point, then you have to place a mass of 1 kg at that point. For example, let us take this point. Okay, this point is A and this point is B. So I want to measure the strength or the intensity of the gravitational field, okay, of the source mass. Then I have to place a test mass equal to 1 kilogram at this point. How much force does it experience? That only is called what? The gravitational field intensity at the point B. So now we come to the point. How do you define the gravitational field intensity at any point? The gravitational field intensity at any point is defined as the force experienced by a unit mass, that is 1 kg, placed at that point. Understand? So, how much force does this 1 kg mass experience at a given point B gives what information? It gives the strength of the gravitational field or the intensity of the gravitational field of whom? Of the source mass. So when I say gravitational field intensity at any point, it means it is the strength of the gravitational field due to the source mass, keeping a test mass of 1 kg. So we are going to derive the expression for that. Before that, in general, if you take two masses, m1 and m2, separated by a distance r. So the center of A is joined with the center of B. Okay. So along this direction only, the unit vector r cap acts. R cap is a unit vector along the line joining the two masses, and it is always from the source mass to the test mass. Keep it in mind. R cap is a unit vector along the direction of the line joining the two masses, but its direction is what? From the source mass to the test mass. Similarly, the force of attraction always must be what? On the test mass towards the source mass. So that this gravitational force of attraction and this unit vector r cap, okay, both are oppositely directed. Keep it in mind. Throughout this chapter, you will be remembering this. Understand? Now, I want to get an expression for the gravitational field intensity at a given point B. Okay, and it is represented by the symbol capital E. Okay, so for that I will begin the derivation with the law of gravitation. Okay, from the law of gravitation, the force of gravitation between these two masses. So F vector is equal to minus of G into M1 into M2 divided by R square into R cap. This is the first equation. Understand that? So this direction is opposite, that is force and R cap, both are oppositely directed. So this is the significance of the negative sign. Now in this equation, what will be the force acting per unit mass? Means F by M, F by M2. F divided by M2 is equal to minus of G into M1 divided by R square into R cap. Now look at the left hand side. It is the force per unit mass. This only is called as what? Force per unit mass. Is it not? So that is equal to minus G into M1 by R square, because this M2 has come to the left side. Here there is no M2 term. And this also is called as what? E. This only is called as the gravitational field intensity at this distance r from the source mass. Therefore I can write E is equal to minus of G into M1 divided by R square into R cap. So this can be taken as equation 2. Okay, now I will assume the first mass M1 is equal to capital M and the second mass is equal to small m. I substitute in the equation number 1. So what I get is F vector is equal to minus of G into capital M into small m divided by R square into R cap. So this can be rewritten as what? M multiplied by minus Gm by R square into R cap. I have taken this M term separately. But inside this bracket, minus Gm by R square into R cap is there. So that is nothing but the gravitational field intensity at the distance R. So I can substitute the terms inside the bracket by the term E. So F vector, therefore F vector is equal to M into E vector. So this is equation 3. Okay. From Newton's second law, F is also equal to mass m into acceleration. This is equation 4. Is it not? So I am going to equate these two. Therefore, m into E is also equal to m into A. So cancelling m on both sides, or I can also write E is equal to A vector. And this is another important relation, equation 5. So from equation 5, what do we infer? At a distance r from the source mass, the strength of the gravitational field or the intensity of the gravitational field is also equal to the acceleration gained by a body of mass m. Is it not that? So both are one and the same. So from this we come to understand that the dimensions of E and A both are one and the same. Okay. So the unit of E is equal to the unit of acceleration. There are two units for this gravitational field intensity. So what is this? Unit of E is what? E is equal to F by m. So it implies the unit Newton per kg. And acceleration is also equal to F by m. This is a meter per second square. Therefore, Newton per kg is also equal to meters per second square. Meter per second square. Newton per kilogram and meter per second square both are one and the same. So, now what is a gravitational field? I told you it is a space or area surrounding any given mass, inside which a test mass experiences a force of attraction. Understand? And how do you measure the strength or the intensity of the gravitational field at the given point? We have to place a unit mass. Understand that? So now if you take, for example, this is the earth. Okay, this is the earth. And this is the gravitational field of the earth. Let us assume this is the gravitational field of the earth. So I will choose randomly 3 points like this. So from the center of the earth, I join all these 3 points, namely A, B and C. Now if I will place a unit mass of 1 kg, okay, at all these points, the gravitational force experienced by the unit mass cannot be same. By inverse square law, who is experiencing a greater force will be at a point A, and lesser force will be at the point C, and intermediate force is experienced by the mass at the point B. So it is clearly understood that the strength or the intensity of the gravitational field is not the same at all points. It is different at the different points. Understand? And it is inversely proportional to the square of the distance. Okay, square of the distance from the center of the earth to the center of the test mass. So finally we have to remember this expression forever. The expression for the gravitational field intensity is E vector is equal to minus of G m1 by r square. E is due to the source mass. And here we have to substitute the source mass m1. And you find that here it is not having a term m2. So what does it mean? The strength of the field will be the same. The strength at this point, whether you keep 1 kg mass or 5 kg mass or 100 kg mass also, the force experienced will be different. But the strength of the gravitational field due to the source mass remains the same. It does not depend on the mass of the test mass. It depends only on the mass of the source. That is the given mass. Okay, students. I hope you must have understood well. Fine.